Hi, my name is Muhammad Nur Hakimi bin Abdullah. My matrix number is 208356. I will explain about the introduction and physical properties of group 17 elements. First, I will explain about the introduction of group 17 elements. Group 17 elements are non-metals and also known as halogen group. Why halogen? So halogen is come from Greek word that means self-producing. This group consists of fluorine, chlorine, bromine, iodine, astatine, and tennessine. So the periodic table below shows the location of halogen group. So next is group 17 elements in nature. So here we have fluorine, which is the smallest atom in group 17. And the biggest one is tennessine. Tennessine is actually a new members of group 17, and before this element is called UUS. Tennessine is the name of tennessine come from the state of Tennessee. So next is the characteristic. In nature, halogens exist in diatomic molecules, which mean by pairs. So we can write it as F2, CL2, Br2, and I2. Most halogens produce halide salt. So what is halide? Halide is the name of the ion of halogens. So there are some salt that come from the halogens. For example, sodium chloride, barium fluoride, sodium bromide, and so on. So next is the physical properties. So one of the most important properties is the color of the halogens. So fluorine, the color is pale yellow. For the chlorine is greenish yellow color as the picture above, as the picture below. Next is bromine, which is reddish brown color, and iodine, dark violet color. Next physical properties is the atomic radius increase down the group as the number of shells occupied with electrons increase. The density is also increased as the molecular weight increase. So for the melting and boiling point, the melting and boiling point for halogens is actually quite low compared to another group, but it still increases as we move down the group because the size of atom. Last one is bond dissociation energy. So bond dissociation energy is the energy needed to release the valence electron from the element. So the bond dissociation energy decrease down the group because of the distance between the nucleus and the valence electron. So the bigger the element, the bigger the atom, so it becomes easier for the valence electron to be released. However, fluorine has low bond dissociation due to the small atomic radius and the absence of D shells. So I will pass to the next presenter.
Hi, my name is Nur Ala Nabila binti Jamal, matrix number 208231, and I'll be presenting about the chemical properties of group 17.
Alright, so now let's move on to chemical properties of group 17. So the chemical properties of group 17 consist of reactivity, oxidizing agent, electronegativity, electron affinity, and also first ionization energy. And I'll be explain each one of it in the next slides. Okay, so for the first one, the reactivity of halogens. The reactivity means that the tendency of the atoms to accept or donate electron to achieve the noble gas configuration state. So in this case, halogens will accept one more electron to achieve the noble gas configuration state, as it already contains 7 valence electron in it. So the reactivity of the halogens will decrease down the group. This is because the strength of nucleus attraction between the valence electron and nucleus is decreased. This is because the increase in the inner shells, the screening effect by the inner shells that containing electrons. So therefore, the tendency of the atoms to accept one electron or to react with other atoms will decrease down the group. Next, oxidizing agents. So oxidizing agents means that the atoms that gain electron and is reduced in the chemical reactions. So as I mentioned before, halogens, the reactivity of halogens down the group is decreased. So therefore, the oxidizing power of group 17 is also will be decreased. This is because the strength of the nucleus to attract valence electron is decreased by the increasing of the screening effect by inner electrons. So therefore, halogens are the oxidizing power of halogen is decreased down the group. As you can see in the figures here, the ability to accept electron will be increased as you the higher oxidizing power is at fluorine and the lowest is at iodine. Alright, so next is the electronegativity. So electronegativity is the tendency of electron to accept electron when to form bond with other atoms. So in group 17, the electronegativity will decrease down the group. This is because as you goes down the group, the size of the halogen increase down the group. So as you can see in this figure here, when the size of the atoms increase, the valence electron becomes further away from the nucleus. So the attraction, so the screening effect by the inner electrons is increased. So therefore, it also result to the effective nuclear charge will decrease. So therefore, all of these reasons will lead to the decrease in the electronegativity of group 17. So in group 17, the most electronegativity is fluorine and the less electronegativity is S13. Alright, next is the electron affinity. So what is meant by the electron affinity? Electron affinity is the amount of energy change when 1 mole of electron is added to 1 mole of gaseous atoms or ions. So as you goes down the group, the size of the atoms increase. So the attraction between valence electron and nucleus will be decreased because it is further away. The valence electron is further away from nucleus. So electron affinity will decrease down the group as the atomic size increase. Other reasons why electron affinity is decreased down the group is because the decrease in effective nuclear charge. So the effective nuclear charge is actually the positive charge that will be the positive charge the electron will have. So when the decrease in effective nuclear charge, the electron affinity will also decrease. But there's a special case where you can see in this table below, the electron affinity should be decreased as you go down the group. But between fluorine and chlorine, chlorine have higher electron affinity compared to fluorine. This is because the size of fluorine is actually much more smaller than chlorine. Alright, so the last chemical properties of group 17 is the first ionization energy. So the first ionization energy means that the energy required to remove 1 mole to remove 1 electron from 1 mole of gaseous atoms. So the valence electron, the same reason as it goes down the group, the size of the atoms will increase. So the valence electrons will become further away from the nucleus. So the attraction between valence electron and nucleus is decreased. So so this is because the screening effect by the inner electrons goes down in the group 17 is become increased down the group. So therefore, when you goes down the group, the first ionization energy is decreased because it is much more easier to remove valence electrons when the atoms have bigger size. It can be proven by this table below, where you have the first ionization energy values is decreased as it goes from fluorine to S13. So that's it. Let's move on to the chemical bonding of group 17.
Morning everyone, my name is Fiza Shafi with matrix number 209424, and today I am going to talk on the topic of chemical bonding in group 17 elements. We know that halogens form different types of bonds. Now if we talk about the types of bonding in halogens, we have ionic bonds. Now what is an ionic bond? Ionic bond is a type of linkage formed from the electrostatic attraction between oppositely charged ions in a chemical compound. Such a bond forms when the valence electrons of one atom are transferred permanently to another atom. Now we have covalent bond. It is formed between metal and a non-metal. Covalent bonding results from sharing one or more electron pairs between two atoms. The binding arises from the electrostatic attraction of the nuclei for the same electrons. We have three types of covalent bonds, that is single covalent bond, double covalent bond, and we have triple covalent bond. Then we have hydrogen bond. A hydrogen bond is primarily electrostatic force of attraction between a hydrogen atom which is covalently bound to a more electronegative atom or group of another electronegative atoms bearing a lone pair of electrons. We have the trends in chemical reactivity. We know that all the halogens are highly reactive elements due to the following main two reasons, that is, low bond dissociation energy and high negative electron gain enthalpies. Also, we know that halogens form covalent and ionic bonds. Halogens form covalent bonds with nonmetals. Also, they react with metals to form halides. Now, if we talk about the ionic bonding in halide salts, we know the large differences in electronegativity between metal and non-metal halogens often results in ionic bonding. The greater the electronegativity between two bonded atoms, the greater the likelihood of an ionic bond being formed. Here we have different examples of sodium chloride, magnesium chloride, aluminum chloride, etc. Now, if we talk about sodium chloride, we know that slightly positive hydrogen are attracted to chlorine anions, and slightly negative oxygen are attracted to sodium cations. Now we have the reactivity towards hydrogen. All the halogens react directly with hydrogen, forming covalent bonds and are at sufficient level of purity and gases at room temperature. Hydrogen reacts with fluorine, chlorine, bromine and iodine. All the halogens combined with hydrogen to form hydrogen halides. Reactivity of fluorine. Because of its high electronegativity, fluorine has highest tendency to form ionic compounds, and thus fluorides have the maximum ionic character. Here we take an example of sodium and fluorine that form sodium fluoride. Here sodium is extremely reactive and fluorine is also extremely reactive. The product which is formed, that is sodium fluoride, is unreactive. Interhalogen compounds. Now what are interhalogen compounds? Halogens react with each other to form a number of compounds called the interhalogen compounds, containing two or more different halogen atoms. All interhalogen compounds are essentially covalent compounds because of small electronegativity differences. Now, if we take examples of two interhalogen compounds, we have bromine trifluoride and bromine pentafluoride. Thanks for watching.
Assalamualaikum and hi, my name is Ardiana Natasha binti Andrisham. My metric number is 207948. Today I'm going to present about application of group 17, which is halogens. Okay, the first elements of halogens that I'm going to present is fluorine. So the application of fluorine is, the first one is plastic polytetrafluoroethylene, which is we call as Teflon PTFE. So this is the first picture. There is a PTFE. So the fluorine actually is the key component of this PTFE. And also the other polymers, which is we refer as fluoropolymers. The next one is chlorofluorocarbons, which is CFC, as a chemical organic that used as the refrigerants and propellant in aerosol. Before growing concern about their possible environmental impact, which led to their discontinued use. So CFC now are being replaced by HFC because the CFC is quite dangerous to the ozone layer. And next one, we have toothpaste as a application for fluorine, which is there is a fluoride ion in toothpaste. The last one is clay, which is used to build ceramics. Next, the second element of halogen is chlorine. So as we know that chlorine actually has many industrial uses. Basically, it used to disinfect drinking water and swimming pool. So the first one is bleach. The main component in bleach is NaClO, which is we can see the example of this bleach Clorox. Also, the next one is hydrochloric acid, which is HCl, which is used in laboratories. Next, chlorine also present in polyvinyl chloride PVC and several other polymers. PVC is used in wire insulation, pipes, and electronics. In addition, chlorine also is very useful in pharmaceutical industry, which is to make medicinal products. Medicinal products containing chlorine are used to treat infections, allergies, and diabetes. Chlorine is also used to sterilize hospital machinery and limit infection growth, such as for this picture, we can see it's sterilized hospital machinery. The last one is in agriculture. Chlorine is a component of many commercial pesticides such as DDT, dichloroethanyl trichloroethane, was used as an agriculture insecticide, but its use was discontinued. The third element of halogen is bromine. Bromine is used in flame retardants because of its fire-resistant properties. It also found in pesticide methyl bromide, which facilitates the storage of crops and eliminates the spread of bacteria. However, the excessive use of methyl bromide has been discontinued due to its impact on the ozone layer. So, the example of methyl bromide is this picture. Next, bromide also used in gasoline production and photography film. The content in fire extinguisher, as well as drug, which is treating pneumonia and Alzheimer's disease. Next, the fourth element of halogen that I'm going to introduce is iodine. So the application of iodine, the first one is used as antiseptic. The second one is table salt. It is table salt contains iodine to help promote proper functioning of the thyroid hormones. Also, we know that iodine actually is very important in the proper functioning of the thyroid gland of the body. And the last one, iodine we use as photography development, which is the silver iodide is used to photography development, such as for this picture, the red one picture. This is the photography development by using silver iodide. The last element of halogen is astatine. The application of astatine actually no proven uses because we know that astatine is radioactive and rare halogen element. However, There is speculation that this element could aid iodine in regulating the thyroid hormone. Also, it has been used in mice to aid the study of cancer. So you can see this picture. Actually, you can see there is the body of mice, and the researchers use astatine to study the cancer cell by using mice. I think that's all from me. Thank you.
Hi, my name is Ukurana binti Ibu Muhammad Azahari. My number metric is 208050. So for my part, I'm going to explain about the introductions of group 18s and its physical properties. So first, I'm going to present about the introductions of 18s, which is also called as noble gas. So what is group 18? Why gases? Why inert gases? So group 18s is also known as noble gases are the last group in the they're also known as inert gases. So why they're known as inert gases is because they do not react with any other elements in the periodic tables. That is why they have a non-reactive behavior. As we can see here, this is a periodic table. So 18 are last group in the periodic table. And you can see here, this is the group 18, which is the last group in the periodic table, also known as noble gases. So this group consists of a chemical series of gases in argon, helium, non-krypton, xenon, and radon. So group 18 elements. So number one is they are non-metallic, colorless gases at room temperature and pressure with a very low melting points and boiling points. Because of they have a very low melting points and boiling points, they are all gases. Number two is they form 1% of air, and most of this is argon in the atmosphere. Number three is all noble gases except radon occur in the atmosphere. So this is physical properties for group 8 helium to radon. So you can see here they have a number, electron arrangement, melting points, and points. So from the electron arrangements, we can see here that all the elements in the group 18 have 8 electrons in the outermost electron shells. Shells except helium. So from here we can know the group of elements by knowing the electron of electron outermost shells, the number of electron in outermost shells. So you can see here that the electrons of outermost shells for this is number 8, which means that they are in 18. Other than that, because of they have 8 electrons in the outermost shell, which this means that they have a very stable. They are very stable and chemically stable, which means this means that they do not need to react with other elements, or they do not need to then open other elements to accomplish octet. So that is why I haven't reacted behavior. From this table, we can see that melting points and boiling points is increased when it goes down the group. But still, we can see that melting points and boiling points is less than room temperature. That is why there are gases. Which is why all the elements in 18s are gases. They have low melting points and boiling points than room temperature. So first is size of atom. So the size of atom increases down due to the increased number of electron shells. As we can see here from this table, this electron arrangement, when it goes down to group, the electron shell is increased. It's 1, 3, 5, 6. So when the electron shell is increased, then the size of atom also increases. Next is we talk about the solubility and conductivity.
So all noble gases are insoluble in water and they are not conductor of and electricity. Next is melting points and boiling point. As I said earlier, the melting points and boiling points of these noble gases are very low. So why they have a very low melting and boiling points is because all noble gases exist are monoatom. So unlike oxygen is a diatoms because they have like two, which means that they diatoms, but group 18 is monoatom. For example, helium, like He, only He, one atom. And the force between He, helium, the force is non-matter because he is non-matter. It's called a van der Waals force. So because of they are monoatoms, so the van der Waals force is weak. So the van der Waals force is weak. Therefore, very little energy is needed to overcome this force during melting and boiling. Next is density. So the density of gas are very low. Nevertheless, the density increases steadily loop down the group. So why the density is increased when it goes down the group is, before that, let's take a look at the formula of the density. So density is equal to mass over volume. So we know that when it goes down the group, mass is increased and same goes to volume. But the increase of mass is faster than the hence the density increases down the group. So that's all for my part. Now I'm going to pass to Aina to talk about the physical properties of weight.
Assalamualaikum and good day everyone. My name is Aina Bushra binti Kunja Muhammad with matrix number 208305.
Okay, continue on the next physical properties, which is the ionization energy. So based on this graph, what we can conclude is that when the atomic number increases, the ionization energy of elements in group 18 decreases. Okay, so why is this so? Because if we see from this Giffey, the atomic size of helium, neon, argon, krypton, xenon, and radon is increasing. Okay. Alright. Okay. So why is it so? Why, when the atomic number increases, the ionization energy decreases? So firstly, when the atomic number increases, the valence electron will be further from the nucleus. So when it becomes further from nucleus, then the attraction of the nucleus toward the valence electron will be weaker. Yeah, will be weaker. So okay, so the atomic radius will be increasing, and we only require a little amount of energy to break the weak bond. Okay. Alright. So moving on to the chemical properties. So before we go in further, have a look on this fat guy. Okay. So he is having an inactive and sedentary lifestyle. So how does it related to group 18 elements is because the elements in group 18 are inert, chemically inert. Okay, so why are they chemically inert? So there are three reasons of why they are chemically inert. So firstly, they have a stable duplet and octet electronic configuration. Duplet for helium and octet for other elements in group 18. Secondly is because they have high ionization energy. And thirdly, because they have almost zero electron affinity. Alright. So just now I said that group 18 group 18 members are inert, right? However, there is a compound called xenon hydrate. So if we look at this name, if we look at this name, we will think of xenon having a bond with other molecules, right? However, this xenon hydrate is actually a class break. So what is class break? So in this class break, the xenon atom is the gas atom, while water is the host atom. So xenon will fill in the cavities between the hydrogen bonded water molecules. So imagine there is a ball, and inside every single ball, we have another small ball, and the small ball is xenon. Yeah. So why? The purpose of xenon, addition in the water molecule is to form a stable molecule. So we need to take note that in xenon hydrate, there is only a molecule formation. There is no bond formation. There is no bond interaction between water and also xenon. Okay. So the reason why xenon is applicable for this function is because its ionization energy is low. However, if we look in the periodic table, xenon is located above radon. So we know if we notice here, the ionization energy of radon should be lower than xenon, right? And yes, it is. However, because of the radioactive properties of radon, it is not extensively explored. The chemical properties of radon is not extensively explored because it is radioactive. So it will harm human being. So xenon is much safer as compared to radon. Then Hafiz will continue on the applications of noble gases.
Hello everyone, my name is Muhammad Hafiz Aiman bin Abdul Rahman 207928 and I will be presenting the application of noble gases.
Hello everyone, now we are going to talk about application of group 18. The first element that we are going to discuss about is the helium. With helium, we can make a helium balloon. We can use it normally as a birthday balloon, or we can also use it to check the atmospheric condition. This works because helium is less denser than air, it can float. So it can float to atmosphere and it can check the atmospheric condition. Like this picture here, we can see that the helium balloon to check the atmospheric condition is very big and it can reach the atmosphere. Next, helium can also be used in cooling gas as a cooling gas in nuclear reactor. Next, we are going to talk about neon. Neon is an element that we can use as a discharge tube. This orange color here is produced by neon. And we can also use neon as the advertising sign. When the electric passes through the noble gas, the electron will get excited. And when they get excited, electron jumps to release the energy. And the energy that is released will matches the visible light. As you can see here, this is the application of neon that has been electric has been passing through them. Next, we are going to talk about the argon element. Argon elements are usually found in light bulbs, especially the energy efficient fluorescent light bulbs, and argon can also be found in transistors. Argon can also be used to provide inert atmosphere. This is to prevent hot welding metal from oxidizing when we are welding the metal. Next, and this atmosphere is suitable for welding titanium, aluminum, stainless steel, and magnesium. Next, we are going to talk about the krypton element. Krypton can be used to make a light bulb. It is usually used with nitrogen to prevent the filament from burning out. This right here that you see right here is the filament, and we don't want it to burn out, so because it will break the light bulb. Next, krypton can also be used to illuminate the landing strip at airport. As you can see here, the krypton is being used to light up the landing strip for the airplane to land on it easily. And next, the krypton can be used as a laser for eye surgery. Next, the next element is xenon. Xenon can be used as a stoplight, and it can also be used as the photographic flash tube for cameras. They are usually installed in electron tube, lamps, laser, and photographer flash gun. And last but not least, radon. Radon is a radioactive element, so it is able to treat cancer. So, because of this, radon is usually used in radiotherapy. We have reached the final slide. Thank you everyone for listening to our presentation, and goodbye.